and then have you try a couple. This is basically going to review what we did last class, except notice there's one slight difference. Right? Now the intervals aren't in terms of pi radians, they're just in terms of an integer, or the integer values here for the radians. So this changes a little bit how the equation's going to look, although, again, all of the same rules are still going to apply. So I'm going to walk through the first one, and then I'll have you try the next couple on your own. Okay, so if you remember the steps that again, and you can do these steps in different orders, but what I'm going to do here is I'm going to find my midline first. So here's my maximum at 1 and my minimum at -11. So what number falls halfway between those? 1 plus a -11 divided by 2 is -10/2 or -5. So that's my midline. Okay, and so I can use sine or cosine for these. Okay, I can do either one. Okay, when I look for my cosine, I don't really see one full cosine cycle, and so I'm not going to use that. I am going to use, though, or what I do see is if I go from this point, then the minimum, then the midline, then maximum, then back to midline again, I do have one full cycle of the sine function with a negative in front, right? Because I go down to the minimum as my first move instead of up to the maximum. So I'm going to be using a negative sign for this. So it asks me to use f of x. I know there's going to be a negative. I don't know my amplitude yet. I am going to use sine. Okay, and so here's my equation, and I need to find these 4 elements, right? So I found my midline. My midline is -5. That's going to go at the end. So that's the first piece that I'm going to plug in. Then I can find my amplitude by looking at what is the distance from the midline to either the max or the min. And you just need to find one of them. So the distance from -5 to -11 is a distance of what? 6. So that's going to be my amplitude. So there's the second element that I found. Again, I have that negative in front of it, right, because it is the sine function, but it's going in the downward direction first. Okay, next, I can find my phase shift if I want. So when I look, the point here that I started with had a total shift of how many units? -5, right? So it's x minus a -5. So that's going to be my next element. And so the last thing I need to do is find my b value. Now remember, the b value is part of this equation. The period is equal to 2 pi over b. So remember, the period is how long what interval does it take for the sine cycle to repeat itself? That is what the period is. But the b value is how many times does it cycle through a 2 pi interval. And so in order for me to find the b value, I'm using this equation right here. Well, what is my period? It goes from -5 to +7. So what's that total distance here? It's a total distance of 12. So I know that this period is going to be 12. So I can use that equation to find my b value. And so finding this, I will simply cross multiply here, or multiply both sides by a b. So those cancel. And then in order for me to solve for b, I'm going to then divide both sides by 12. Those cancel. So I get b is equal to 2 pi over 12, which reduces to pi over 6. So there is my b value, and I've completed my equation. Okay, so the process is identical to what we did before, okay, except now you're just working with the integer values on the x-axis instead of the irrational values with fractions of pi. Okay. Elliot, did you have a question? No. Okay. All right, so I want you to try the next one. Okay, the next graph is one, again, where you have enough information. You see one full, you see a sine cycle and a cosine cycle. Okay, but use the one, or it tells you specifically here, it wants you to use the sine function. See if you can write that equation in terms of sine, okay, based on those, again, finding those 4 key elements to the equation. All right, so it asked me to find in terms of sine. Okay, to me, the easiest way to go through and approach this is find my midline first, a maximum at 6, a minimum at -2, find the halfway distance between that. So 6 plus a -2 is a +4, divided by 2 is 2. You could also count it through, right? But you get your midline to be plus 2. So there's your last piece of, or the last element that you need to enter into your equation. Okay. Next is we need to determine what is the amplitude. Well, from 2 to 6 or from 2 to -2, those are the same distance. And what is that distance? A total of 4. Okay, so you know that your amplitude is 4. We haven't decided whether we're using a positive or a negative yet, okay, because it all depends on where you want to start your cycle. Okay, so if you take the sine cycle and begin it right here, are we going to have a +4 or a -4? If we go down, if we use this as our cycle, we're going to use a -4. What if we used this piece right here? +4, we could have used this piece here, this cycle, also would be a +4. So however you decide, whichever piece you want to use, you can choose whatever you want. I'm going to use this portion right here, since I've already highlighted it, or I highlighted it first. And so I'm going to choose a -4 for my multiplier out front. Okay, which also tells me this is my shift. My horizontal or phase shift, horizontal shift is -1, so x minus a -1 is what I would write. And then my final piece is to calculate my b value, which goes right here. Okay, and so my b value is the period is equal to 2 pi over b. The period, when I look to see how long does it take for one cycle to repeat, so here is the portion that I'm looking at. This is one cycle of the sine function. Goes from -1 to +5, which is a total distance of 6. So if I calculate this, set it equal to 6, and solve, I'm going to multiply both sides by b, get that out of the denominator, then isolate it by dividing both sides by 6, and 2 pi over 6 reduces to pi over 3. So there is my equation for that is representative of the yellow portion of this. Now, this is not the only equation I could use. Okay? Again, what if I had chosen this portion right here? If I had chosen that portion, and I'll rewrite my equation, I still have a amplitude of 4, but this time I'm going to use a positive. I still have a b value of pi over 3. That doesn't change. Everything stays the same except for my phase shift. Okay? The leading sign might change, and then the phase shift, the horizontal shift, will change. So here, when I look at this, the shift that occurred here with my graph, it moved to the left how many units? -4. So both of these would give you credit for this question. Okay? You can choose either one of them. All right, let's try one more so you practice both sine and cosine. So try doing the same thing with this equation here using cosine. All right, so I've labeled all the pieces that you need to find. Okay, when you're looking at this, you see that you have the only thing that you can actually see in the interval that they provide you is one cosine cycle, right? And this cycle is representing a negative cosine. So we do know that we're going to have a negative out front based on what we see right here, okay? Since we're starting with a minimum. Okay, so the first thing is, let's find our midline. So maximum at 10 and a minimum at -2. So if we take the average of those, we find the midline. So 10 plus a -2 is 8. Divide by 2 is 4. So there's our midline. Okay, so +4 is the first element I add to my equation. I can then find my amplitude. The distance from the midline to the max and the min from 4 to 10 has a total distance of 6. So a -6 cosine of whatever our b value is, which we'll find in a bit. Let's use our shift. Well, we took this point right here. So when we look at our phase shift, it goes all the way over 7 units to the left. So x minus a negative 7 becomes x plus 7 inside our function. And then the last thing is to find that b value. And remember, your period is equal to 2 pi over b for sines and cosines. And if you count one period here, from the minimum to minimum, negative 7 to 5, that's a total distance of 12. Okay, so this graph, it will repeat itself every 12 units. And so here, if we multiply both sides by b to get it out of the denominator, and then isolate it by dividing both sides by 12, we get 2 pi over 12, which is, again, pi over 6, and that would be your equation. So based on what we see in this graph, and we can come up with this equation. All right. Questions on that? So that's a review of all the different types of questions that you're going to see where you're going to be asked to find an equation based on a graph. And the remaining questions that we're going to look at here are going to be how do you sketch a graph when you're given the equation. All right. So when I ask you to sketch a graph, I'm going to give you all three of these elements down here. I'm going to give you the line tool. The line tool is not going to be part of your equation or part of your solution. You're not being graded on it. I simply provide it so you can use it as a reference line when you're sketching everything. You don't need to use the line tool when you graph these, but you do need to, if you are going to use it, you do need to remove it before you submit your answer. Okay, so if you include it in the answer, it'll be marked wrong. It's simply there to use as a reference if you want to see where your midline is located. Okay. All right. So what we're going to do when you are sketching is you need to establish what is the period. Okay. So when you are looking at your the period here for this graph, the period for sine and cosine is 2 pi over b. Okay, so b is that multiplier in front of the x. If you want to, you can think about it as being, if you remove whatever the coefficient of x is, so here pi over 32, okay, and then that's x minus 0 if you're thinking of it in terms of the general form that we've looked at, right, minus 0. There's no vertical shift either, so you could also think of that as a plus 0. So your midline's going to be just along the x-axis. Okay. Your amplitude is this number in front. Absolute value of -1 is 1. So your maximum's going to be 1, your minimum's going to be -1. And so all you need to do right here is, if you have no shift, you know that your first critical point, which for a sine function is what? The midline, maximum, or minimum. So for a negative sine, it's going to be midline. So your first critical point is going to be the midline. There's no horizontal shift. And then the last point is going to be whatever the period is. So if we took 2 pi divided by our b value is pi over 32, which is the same as multiplying by the reciprocal 32 over pi. The pi's cancel, you get 2 times 32, which is 64. So our final point is going to be at 64. So 0 and 64 are the first and the last point in one cycle of our, or one period of our function. And so what we can do is we want to take the first and the last points, and to find the other 3, we cut this in half. So half of this is 32. And then we cut each of those in half as well. So halfway between 0 and 32 is 16. And halfway between 32 and 64 is 48. So those are our 5 critical points for this graph. Okay, so once you find your 5 critical points, you can then use the pattern of your sine or cosine, whether it's positive or negative, to label what you have. So a negative sine begins at the midline, but then it goes to the minimum, and then back to the midline, then the maximum, and then back to the midline. So that is the pattern that you would put. So when you plot your points for this sine function, which is this graph right here, you only need to plot 2 points, right? you plot the midline, and then you plot the max or min. It can be either. Okay, it's just that next consecutive critical point. So this would be the first point I'd select. My next one is the minimum. So then I'd come down here at this point, 16, -1. And once you do that, it's going to sketch that graph for you. So it'll fill it in here, come back up, and it'll snake through. Okay, and so that will fill in the rest of your graph as long as you plot these 2 points. All right, I want you to try the same idea, though, with the next problem, which is a cosine function. Okay, see if you can follow that same set of reasoning, okay, and come up with your graph. So once again, I'm going to think of it in terms of all of the transformations. I'm going to take out that b value in front of the x and see what all happens with my other transformations. There's no horizontal or vertical shift here. And so what I can do is find my b value. Period is 2 pi, or find my period. The period is 2 pi over b, where b is pi over 24. Dividing by pi over 4 is like multiplying by the reciprocal. Pi's cancel. 2 times 24 is 48. So I know that this graph is going to repeat every 1 cycle during an interval of 48. So my first critical point, again, I have on my max and my min, doesn't change. That's the multiplier in front of cosine. Okay, so I'm going to start, or my interval starts at 0 and ends at 48. And so when I calculate my remaining points, so here's my 2 endpoints of my critical points. Halfway between is 24. And then halfway between each of those is 12 and 36. So there's my 5 critical points. For my cosine, a positive cosine, I begin at a maximum, and then I hit the midline, then a minimum, then a midline again, and then back to the maximum. That's 1 full cycle. Okay, so if I'm selecting this, I have a maximum point, then a midline, then a minimum, midline, maximum. So those are the points that I would sketch if I was doing this by hand. When you choose the graphing utility for cosine, notice that it takes the maximum and the minimum are the 2 points. So when you select the points here, you're going to need to select a maximum and then the next consecutive minimum. Okay, so those are the 2 points that you would choose in order to get your graph, and then it will fill in the rest of it based on that. Okay, and so that winds up being what your graph looks like, okay, after filling in just this portion of it. All right, I'm going to have you try the next one on your own, and the next one includes the other transformations. Okay, I want to see what you can do on your own before I talk through it. Okay, so see if you can sketch the graph here. So notice the grid marks here are fractions of pi. Okay, they should be set in a way that you can label the different critical points in terms of that fraction. Okay, so it might just be every pi over 6, but it might also be every 2 of those pi over 6s and so on. All right, so I'm going to talk through here the process I would use. So you don't have to do it this way if you have a different way that you used that works for you. Okay, but I'm going to establish my midline first. Okay, so my midline can be found by my vertical shift, right? So my midline is going to be -3. Now, whether you actually sketch this or not, it's up to you. Okay, but if you click this and you draw in this line to use as your reference, all you need to do is make sure before you hit submit on the question that you take whatever point you use to create that line, and what you would do is you would click on that point like this, and then you just drag it somewhere off of the graph, and then when you let go, it should remove just that graph. So you don't have to hit clear all on that. If you created your line and you want to remove it, just click one of the points for the line and just move it off to the side where it's off of your graph, and then let go of it, and it will disappear from that. Now, that's much harder to do on your iPad. Okay? It's easy to do on a computer. So just be aware of that. If you're using an Apple Pencil, it probably, you can do it on your iPad. But if you're using your fingers to control it, it's much harder to do that. Okay, but that's the first thing. Establish your midline. Okay, and then the next thing is to use the phase shift. And the critical points. To plot one point. Okay, so here when I look at this here, I know I'm dealing with the sine, so that's going to be this graph right here, midline to maximum. Okay, my sine in front is a minimum, so I know from the critical points that this is going to go from midline to minimum, right? This is my pattern for the graphing utility. Okay, now this is the rest of the pattern, but all I need to do is find those first two. So here's the pattern I need to sketch my graph. So if I use my horizontal shift here, I'm moving 7 pi over 6 units to which direction, the right or the left, based on that equation? To the right, right? So if I go 7 pi over 6, so if each one is pi over 6, I go 1, 2, 3, 4, 5, 6, 7. So here's the point I go to, and that's going to be a midline. So I'm going to plot my first point right here. I know that that's where my first point goes. Okay, so that's going to be plotting that point. And then the next thing I need to do is I need to establish my critical points. Okay, and so my critical points are going to be based on the period. Okay, so if I look at the period for this is 2 pi divided by what's my b value? In this, my b value is 1, right? The coefficient of x. So my period is just 2 pi. Well, 2 pi is how many pi over 6? It's 12 pi over 6. So I'm going to go 12 pi over 6 from here. So 7 pi over 6. And I'm going to move over to 12 pi over 6. So here's 7. I need to go 8, 9, 10, 11, 12. Okay, so this gives me my 1 period. Okay, so I know that my second critical, or my last critical point is right here. So here's my first and my last critical point for 1 cycle. Okay, what is my amplitude? You're going to find your max and your min values. Okay, so I know that my maximum value here is 4 units. My amplitude is 4, so it's 4 units above this line. So my maximum is at 1. My minimum is at -7. Okay, so I find that max and min using the amplitude. Okay, and so when I look at my critical points, I'm going to cut this whole thing in half. Well, what's halfway between 7 pi over 6 and -5 pi over 6? So pi over 6. So here's my middle point. Okay, and then I'm going to cut each of those in half. So if I look again, I count over 3 units from each. So those are my 5 critical points. Okay, and so if I see that this is 1, 2, 3 pi over 6 for each critical point, right? So I have another critical point over here. Okay, and if I'm going from my midline to my minimum, so here's my midline is the first point, so I need to go to the minimum for the next critical point. The minimum is down here. So if I plot this as my second point, my graph will complete itself from this. Okay, so it'll come up, be a maximum here, midline. It'll be a minimum here, midline. Okay, and so that portion is all you need, just 2 consecutive critical points for your sine, okay, in order to get your whole graph. Okay, and so that will be the function or the graph of this function. All right, try the same thing here with the cosine, please. All right, so let's talk through sort of the process of working and establishing the graph for this function. Okay, so the first thing is to realize you're dealing with a cosine. The cosine is this button from the graphing utility, the one with the max and the min, okay, are the points that you're going to select when you choose points to plot your graph. Okay, and so if we establish what we have here, based on our equation, we know that our vertical shift is 3. So I'm going to have a midline at 3. Okay, so if I kind of sketch that, and I provided the graphing utility, the line utility here. You can use this if you want to identify where the midline is. However, in this particular case, that's maybe more helpful on the sine graph because you're actually plotting points on the midline. Whereas for the cosine utility, you're plotting a max and a min. So you don't necessarily need to know the midline if you know what the max and min are. And we'll base that on this midline. So the maximum and minimum are the absolute value of 6 units above and below this midline. So above it is 9. So there's my max. And below is -3. There's my min. And so I can use my amplitude here to find where those max and min points will be. Okay, and then the last thing, or the next thing, is to identify, based on this cosine graph with a positive coefficient, positive multiplier, your critical points, your 5 critical points are going to start at a max, and then the midline, and then the minimum, then the midline, and then back to the max. But keep in mind that in your graph, you're just going to plot those two, right? You're going to plot the max and the min. That's what it is asking you for using this function. Okay. Right, so the next thing we'll do is use the phase shift in order to find where is that first point, the maximum point, going to be plotted. Well, we know it's going to be our maximum, so a y value of 9, but it needs to be how many units and in what direction based on this? What is the horizontal shift here? -7 pi over 6, right? 7 pi over 6 to the left. So if I can't see it, and sometimes it's hard to see because the numbers sort of overlap over each other, it tells you that each of the grid marks is pi over 6. So 1, 2, 3, 4, 5, 6, 7. So here's the maximum at -7 pi over 6. So this is the first point that we're going to plot. Okay. Now, in order to find the next points, what you're going to do is you're going to use the period. The period is 2 pi over b, and what is our b value here? Once again, the multiplier in front of x is 1, so it's just going to be 2 pi. But in terms of sixth, once again, it's the same as what we saw with the other example. That means that if we think in terms of the grid marks, okay, it's going to be 12 pi over 6, so 12 grid marks to the right of this point is going to be the end of that cycle. So that's where the other maximum, this point right here, is going to fall. Okay, so if this portion from here to here is 7 of those, I need to go how many more? 1, 2, 3, 4. So this 5 more gives me a total of 12 pi over 6. So now I've established my full one period here. So my critical points are here and here to start with. So I'm going to cut those in half. So halfway between 7 pi over 6 and 5 pi over 6 is going to be what? Negative pi over 6, right? Take the difference, 2 pi over 6, cut it in half is 1 pi over 6. And then halfway between each of these, I can mark. And here, oops, I can do this visually. So here I go 3 tick marks over each time. And so what I can see is in my critical points, I have a maximum, my next critical point, a midline, my next critical point, a minimum, my next critical point, midline, my next one, a maximum. Okay, and so here would be the sketch of my graph. Okay, and the portion that, or the points that you're going to actually establish is this maximum and this minimum. you're going to select those two values, and the entire graph will self-populate based on that graphing utility. But once you get to this point right here, it will fill those in for you. Right. So the very last type of question that we're going to look at here is one where there is a coefficient in front of the x. Okay, so I'm going to talk through one of these and then have you try the last one. Okay, I'm going to talk through the one with the cosine first, and then I'll have you do the sine on your own. Okay. All right, so let's again kind of go through all of the same steps. Right, you're going to determine or identify the midline. Okay, so my midline is 3. Okay, I'm dealing with a cosine. So my cosine, again, is going to be this function here. And the order of critical points, because there's a negative in front, what's my very first critical point going to be? For the cosine, it's going to be a minimum, then midline, then maximum, then midline, and then minimum again. Okay, and so these are the 2 points that I'm going to plot on my graph based on the graphing utility, right, of choosing the cosine. All right, so I'm going to go ahead and find my max and min based right here, because if I use the absolute value of the leading term, the amplitude is 4. So I'm going to go 4 units above to get my max at 7. I'm going to go 4 units below to get my minimum at -1. So there's where I'm going to be plotting my points. And then finally, use the phase shift. And the period. And to plot my points. Okay, so this is going to be kind of a multi-step. The phase shift is going to allow you to find your first point. Okay? So here, when I look at my phase shift, what I'm going to do is I'm going to take this function. I'm going to remove the leading coefficient, or the in front of the x. And when I do, I'm left with an x and a -3. Right? And then that's all +3. Okay, so you remove your multiplier inside your function. That's your b value. And then you can see what your shift is. So where is this graph going to be shifted? It's going to be shifted to the right. How many units? 3 units. So I'm going to start a minimum right here at 3 units to the right on that phase shift. Right. The next part in working through this is to determine, based on what I see right here, what is going to be the what's going to be the period. Okay, so how do we find what our other critical points are going to be here? Okay, and so if I take the period is equal to 2 pi divided by my b value. Well, my b value was this multiplier in the coefficient in front of the x, so pi over 2. And pi over 2, dividing by pi over 2 is like multiplying by the reciprocal 2 over pi. So the pi's cancel. 2 times 2 gives you 4. So that means that this graph is going to repeat every 4 units. Now, if I try to work to the right, like we mostly do, right, working left to right, I run out of space. Okay, my minimum here, I need to go all the way over to 7, but there's not enough room to, it doesn't show 7 on there. So what I'm going to do is I'm going to just go in the opposite direction. Still 4 units away. So 1, 2, 3, 4. And so I know there needs to be another minimum 4 units away from this, because this is what the period is. The period, it completes 1 cycle in 4 units. Okay, and so what I can now do is I have critical point here and here. I can cut that in half, and then cut each of those halves in half. And that's going to give me my 5 critical points for the minimum, midline, maximum, midline, minimum. Okay, now, what I wound up doing is I'm using this left point to start with. So that's my minimum. And then I'm going to have a midline, and then a maximum, and then a midline, and then a minimum again. So if I plot, all I need to do is plot a consecutive max and min. So if I plot this point first, because that's what I get from the phase shift, if I then plot this point second, it will complete that graph for me. And so that's all you need to do is select those 2 points here and here. And when you do, it's going to fill in this graph. And again, it will continue and fill in all the rest of that for you. But all you needed was to fill in this point, and it will complete the graph for you. All right, so I want you to try the problem on the left using the same idea but with the sine functions. And can you sketch that? All right, so when you're completing this process, you have a sine function. My midline is 4, so I'm going to plot my midline first. Okay. It's a sine function with a positive, so I'm going to start at a midline, then a maximum, then midline, minimum, midline. So here's where my 5 critical points are going to be. And what I'm going to do is I'm going to take my equation as it's written up above, and I'm going to write it by factoring out that multiplier in front of the x. So I'll take out a pi over 4, leaving x plus 5. And so this is going to allow me to see my phase shift a little bit better too. So I go from my midline of 4. I have an amplitude of 6. So I'm going to go up 6 units to get my maximum at 10. I'm going to go down 6 units to get my minimum at -2. And then I can use this phase shift right here. I need to shift my graph in which direction and how many units. It shifts 5 units to the left. Okay, and so I'm going to start with a midline. So there's my first point that I'm going to plot. This is a sine function, so I'm going to choose the sine graph, which asks you to select the midline and then a max or a min as your next point. Okay, so I do need to find, based on the period of this graph, how long does it take for this this one cycle of the sine function to repeat. So my period is going to be 2 pi divided by b. My b value was pi over 4. So I multiply by the reciprocal 4 over pi. The pi's cancel. 2 times 4 is 8. So this graph is going to repeat in 8 units. So here's 5. It's going to go all the way over 3 more units past that. So there's the period of 8. It's going to end on a midline as well. So what I can do is cut this into half and then halve each of those. So cut it into quarters. So if I take -5 plus 3 is -2 divided by 2 is a -1. So there's the midpoint. And then cut each of those in half as well. So there's my 5 critical points. So I go midline, then maximum, so up here, then midline, then minimum down here, and then back to the midline again, which I already have. And so with the graphing utility, when I select the sine, I just need to plot these 2 points, and it will complete the whole graph for me. And the graph's going to oscillate down and through. And so that's what my graph should look like, and it will, again, the graphing utility will fill in the rest of it. All right. The final type of question that you're going to see is all of this same stuff, except it's going to ask you to graph it in degrees rather than radians. Okay? And so I want you to try these 2 here really quickly. There's no vertical and horizontal shifting on it. Okay, but I want you to see if you can quickly sketch both of these graphs based on what you now know in converting the equation into the graph form. So again, the idea is that you can work through these pretty quickly, especially since there's no additional shifting. Okay, what is the amplitude of our first problem here on the left? It's just the multiplier in front, right? So 5/2. It is a fractional form, so this is somewhat new. We haven't looked at an example like this. Okay, and then to find the period, you're going to take 2 pi divided by b. Well, we don't have radians anymore. We have degrees, so 2 pi is equivalent to how many degrees? 360. So we're going to take 360 divided by the number that's in front of our angle, which is 1/4. Dividing by 1/4 is like multiplying by the reciprocal 4/1. And so we get the period to be 1440. Okay, since there's no vertical shift, our midline is just the x-axis, and our max and our min are 5/2 above that. So here's my maximum, at 2.5. And here's my minimum at -2.5. Okay, from that, from the x-axis. Okay, and so there's no horizontal shifting either. So because it's a sine, we're going to start at the midline, and then it's a positive sign, so max, then midline, min, and then midline again. So here's my 5 critical points. So I am going to start at the midline. So that starts at the origin 0, 0. Okay, my overall period is 1440. So here's one cycle has to complete in this distance. So here's my start and stop point. So I cut that in half, and I cut each of those in half. So there's my 5 critical points. So I'm going to go up to the maximum here. So again, as far as the graph is concerned, for the sine graph, I plot my midline and then a maximum. So if I go up and I plot my maximum right here, just completing those 2 points should fill in the rest of your graph, and it will give you the graph of this equation that you're looking for. Okay, and so that's the only portion that you need to identify, and it will auto-populate the rest. Okay, and then the one to the right, using cosine with all the same idea. Your amplitude is the absolute value of the number in front, the multiplier 9. The period can be found by taking 360 divided by the multiplier in front of your angle, your degree measure, your variable here, which is 1/4. So once again, it's like multiplying by 4, giving you the same period, 1440. Okay, so that was this period as well. Okay, and so when you plot this, you know that your amplitude of 9 goes from, there's no vertical shift, so we move up 9 for our maximum, down 9 our minimum. Okay, and because we're dealing with a cosine, we start a positive cosine, we start at the maximum, midline, minimum, midline, maximum. So there's your critical points. And on the cosine function right here, when you graph it, you're just taking consecutive max and min. So those are the points that you're going to plot. And so if we start at a maximum, here's where our first point will be. The period is 1440. So it's going to end here. So here's your end critical points. Cut that in half. Cut each of those halves in half. Okay, and so when we look a maximum, our next is the midline right here. Next is our minimum, which is down here. Those are the 2 points that you are going to plot in your graphing utility. Just completing those 2 points is going to give you your whole graph, but come back midline, maximum again. And so this is going to give you the graph that you're looking for. Okay, and so that would be the portion of the graph that will give you the solution